So hi everybody, Michal Migurski. And as Tyler mentioned, I've worked at a bunch of places. Today I want to talk about warehousing pixel data in my context as the CTO at CARTO. I've also worked at a bunch of places like Felt, Meta, Remix, MapSense, Stamen, and so forth over the years. Perhaps influential. Thanks, Tyler. For those not familiar with CARTO, we specialize in spatial analytics built for the cloud. And for us, cloud means big data warehouse companies like Snowflake, Google Cloud Platform, et cetera. And we're really starting to get into thinking about rasters and pixels in those environments. So today I want to talk a little bit about the kind of big format of this conference, GeoParquet, and a microhistory, give a brief primer on raster analytics, talk about our format, RaQuet, and then what's next for that. So in terms of GeoParquet microhistory, I think I mentioned the kind of data warehouses above. Some of the first calls to these data warehouse vendors around supporting formats like GeoParquet came from the CARTO Spatial Data Science Conference 3 years ago, and our founder, Javi de la Torre, actually has led and helped that process since the start. And really, two goals we're focused on fairly early. One, those data warehouse environments really prefer tabular inputs, so hence the underlying Parquet data format that makes geodata acceptable to these folks. And then the second one is this kind of NDB, OutDB classification. Linked resources like those used in stacks are always going to be sort of second class to some of these folks, and that really influences a lot of the decisions that we make in our day-to-day work at CARTO. So we're starting to think about raster data, and I really want to get beyond the idea of raster as photos from space and give a couple of examples of the kinds of questions that pixels in a database can answer and why they're so interesting to us. One type of answer might be, let's say I'm a telecom working with wireless information. Where should I put my antennas? Perhaps I would use something like SRTM or another global raster that has float 32 elevations that allow me to map signal propagation. Another question I might try to answer is, what kind of land use do I see inside city limits? For that, I might use a data set like the National Land Cover Database from the US government. That's a compressed index of different types of land usage all around the country at a very high granularity. Maybe I want to ask a question about how many people live near a site. For this, I might use a data set like the High Resolution Settlement Layer, which is a population density at extremely high resolution that I supported as a manager at Meta several jobs ago. So talking about raster at CARTO, we actually announced support for this back in 2024 at our Spatial Data Science Conference. Little plug, if you're interested in this topic, we've got 2 of these this year, one in London and one in New York City. We'd love to have you there. And really the focus at these announcements was how do we get raster data and pixel data into SQL functions and components. The kinds of interfaces that normal spatial analysts use in data warehouses, but allowing them to do things like aggregating rasters. So this year we've started to share our internal format, and actually Jed, I believe, was responsible for the name RaQuet. And it has a whole bunch of features that make things really, really easy for interacting with these data warehouses. One, everything is in the database. Hugely important feature. Pixel values go right in cell byte arrays, gzip compression for efficiency. You can emit rows with NaN values, so that actually makes it super efficient to store that stuff right there where your data lives. Second, we're taking advantage of column-oriented structures and things like Parquet data and the actual data warehouses. So all the bands are stored as columns, and this makes it actually really trivial and easy to blend int and float types. And then last one, this is actually where it starts to get kind of controversial, is we presently only support Web Mercator. So integer zooms, spatial indexes are super simple, Bing tile int64s. It makes raster ops really easy, but it leads to the #1 piece of feedback we get, which is what the hell with other projections? How can you support other forms of data, perhaps UTM or other things that are, I don't know, equal area or other kinds of properties you might want from a projection? The second big piece of feedback we get is what the heck about other data formats? And here I want to give a little shout out to the team at Wherobots that have been working on something called Havasu, based on PostGIS-raster, published by that company, mix of NDB, OutDB. So what do we actually do in order to bring those things together? So this is kind of the message of today, which is we're working on aligning Havasu and RaQuet. Gia from Wherobots has published GitHub PR 259 on the GeoParquet repo. I super strongly recommend you go check it out because we want to know what's missing. We're looking for conversation about this. We want feedback and input on it. Please check it out. and help us create a really great format that starts to bring all these different feedbacks and benefits together so folks can have pixels right there in their warehouses. Thank you.